Hello everyone, welcome to my next lesson on practical coastal navigation. First, I need to state my standard disclaimer. These navigation videos are for educational and explanatory purposes only. They are not intended to guarantee your safety on the water. Nothing, including these videos, can take the place of accredited courses from qualified instructors and developing your own navigation skills over time. You are responsible for choosing destinations and cruising areas that are within your own level of experience and ability. Any charts you may see in this video are not for navigation purposes. They may be out of date, and they are for explanation purposes only. When you go out on the water, you are enjoying yourself at your own risk. In the last lesson, we looked at how ocean and intertidal depths are displayed on Canadian charts. We saw there are these two limits that tides rarely go outside. The limits are called the lower low water of a large tide and the higher high water of a large tide. And the lower limit is also called chart datum. Depths on Canadian charts are written in meters below chart datum, and the heights of tides in the tides and currents tables are given in feet or meters above chart datum. In this lesson, we'll look at the details of how to look up those tide heights in the tides and currents tables. The tides and currents tables are published annually by the Canadian Hydrographic Service, and they're available for download from their website. In this lesson, we're looking at the tide tables. In the next lesson, we'll look at the current tables. Okay, first, let's look at the table of contents for the tides and currents tables. First, you can see the different regions covered in this volume, which is Volume 5. Volume 5 covers Georgia Strait. This map shows the locations of the primary reference stations for tide heights, shown as small black dots. The currents reference stations, or passes, are shown as small black squares. When you're looking for tide heights for your location, you can use this picture to help you find the closest primary reference station. And the inset on the lower left of this page shows you the areas covered by Volumes 6 and 7. If you're going to Desolation Sound, you need to get Volume 6. Then this page is the table of contents. It directs you to the tables for each primary reference station. These stations are the primary tide height stations detailed in Volume 5. There are primary reference stations and there are secondary reference stations. For each primary reference station, there is a complete set of tables with an entry for each and every date in the year, which details the times and heights of the high and low tides for those dates, which we'll look at here in detail. The secondary reference stations only provide a correction to the information provided in the primary reference stations. You need to do a calculation to determine the times and heights of the tide at secondary stations. Okay, let's look at a typical page of the table entries for a primary reference station. This is an example of one page of the tables for a primary station. The name of the station is at the top of the page. Also shown is that the times are provided in standard sun time relative to universal time for this time zone. This is Pacific Standard Time, or UTC-8. The tables never switch over between standard time and daylight savings time. So if you're using the tables in summer and daylight savings time is in effect, you need to add an hour to all these times to get your local time. I always instruct my students that if anyone asks them to look up the time of the next high or low tide, look up the time, add the hour, and then always reply with the words daylight savings time. It saves confusion and having to ask every time, did you add the hour? There is a table entry for each and every day in the year. Let's look at an example table entry to see exactly what's there. At the start of every season, it may have been a while since you last checked these tables, so your memory could be a little fuzzy on how to read them. The best way to remind yourself is to look at the top of the tables. The column headers tell you exactly what's there. The columns go down the page day by day and then move to the next column to continue. Here, we're just looking at the top two entries for July 1 and July 2. Then it continues down the page until July 15, and then it continues in the next column with July 16 and 17. The column headers alternate between English and French, but each contains the same information. And each day is abbreviated with both the English and the French. The entry for each day provides the times and heights for the highest and lowest tides that you will experience on a given day or days in question. Heights are given in both feet and meters. You can use whichever you're most comfortable with. Personally, I like using feet because then I don't have to think in terms of meters and tenths of meters. Now, there's no specific indication here to tell you which is a high tide and which is a low tide, but it's self-evident just from the heights shown. The higher numbers are high tides, even if they're very close together. The lower numbers are low tides. For the basic cruising standard, you need to be able to identify the times and heights of the high and low tides on a given day. For example, in this table, on July 17, there are high tides at 5:05 and 17:06 daylight savings time of 9.2 and 7.9 feet respectively. Then there are low tides at 11:33 and 22:51 daylight savings time. In this case, they're both at 4.9 feet. And just one minor cautionary note, these heights can be affected by weather and winds. Let's look at a real example of one useful way you can use the information in this table. If, for example, you're anchoring in a nearby cove overnight. Let's say you're setting anchor at about 4 o'clock in the afternoon, daylight savings time. And as you're about to lower the anchor, you check your depth sounder. It indicates you're in 20 feet of water, and your anchor chalk is 5 feet above the water. So I'm not going to discuss anchoring here. I'll prepare a complete lesson on anchoring in the future on board a boat. But for this lesson, just suffice it to know you need to set out enough anchor line or anchor road for a scope of 5:1. So with the seabed 25 feet below your anchor chalk, you need to play out 125 feet of road for a scope of 5:1. After the anchor is set and before you settle in for cocktails, you need to reference the tide tables to find out 2 important pieces of information. First, if the tide should go up a long way overnight, will you have enough road played out to keep your scope of 5:1? And second, if the tide goes down a long way overnight, will you have enough room from shallows and other boats for your boat to swing around if the wind comes up and pushes your boat back? It depends on what the weather will do overnight. Okay, so let's say it's July the 1st and we've anchored at 4 p.m. daylight savings time. Let's look at the details. Let's isolate this table to just the days in question. On July 1st, there was a high tide at 12:03 daylight savings time of 8.5 feet. Then it's followed by a low tide of 5.6 feet at 19:28 daylight savings time. So in a period of 7 hours and 25 minutes, the tide will drop about 2.9 feet. That's about 0.4 feet per hour. If you anchored at 4 p.m. daylight savings time, then in the 4 hours since the high tide at 12:03 daylight savings time, the tide will have dropped about 1.6 feet. So from 8.5 feet, it will have dropped to 6.9 feet above chart datum. But guess what? The tide is going to reach a maximum of 11.2 feet overnight at about 2 a.m. daylight savings time. So after you've anchored, the tide will continue to drop about another foot, but then it will go back up again to 11.2 feet overnight. That's a gain of around 4.3 feet above the 6.9 feet at the time you anchored. So for an additional 4.3 feet of tide overnight, you should add another 21.5 feet to keep your scope of 5:1 for the deepest tide overnight. There are also interpolation tables that look like this, along with a complete explanation how to use them in the back of the tides and currents tables that you can use to perform this calculation more precisely. Personally, I'll add another 25 to 30 feet of road to set a margin of safety. I'll also check the weather forecast for overnight, and I may set out even more road depending on the expected winds and how protected the anchorage is. Okay, so now you have enough scope out for the deepest overnight depth. But then what will the tide do after that? The tide will drop all the way down to 1.6 feet at 6:40 a.m. daylight savings time the next morning. So now you may have excessive scope out if there are shallows nearby. Since you set enough scope for 11.2 feet, and since the tide will drop by about 10 feet from that, you may wish to wake up early and take in about 40 to 50 feet of road. Another example of when you'll need to check these tables may be if, for example, you're planning to enter a cove or harbor through a shallow area, and you need to make sure there's sufficient depth for you to enter safely. You can perform a similar calculation. Check your charts for the depth below chart datum, then add at least an extra meter below your draft. Then if it's a rising tide, estimate the earliest time to get through, and if it's a falling tide, estimate the latest time to get through. In both cases, make sure the area you're transiting is within your navigation abilities before attempting to get through. Now, let's take a look at secondary stations. These calculations that I've done so far are by referencing the detailed tide tables for the closest primary station. But there are secondary stations as well. We can check the table of contents again and note that on page 112 for volume 5, there is a complete explanation of how to calculate time and height differences for the high and low tides at secondary stations. There is also a sample calculation provided there, so I'm not going to do a detailed calculation here. I'll just note the major steps. Table 3 on page 124 in volume 5 lists time and height corrections. You look up the tide times and heights in the detailed tables for a primary station, then apply the time and height corrections you find in Table 3 for a secondary station. For example, in Table 3, these are the secondary stations to the primary station of Souk. First, there are time corrections to apply. These are the time corrections for high tides, and these are the time corrections for low tides. You look up the high tide and low tide times for Souk, then add or subtract these corrections for the secondary station. For example, if you're at point no point, wherever that is, high tides occur 22 minutes earlier than the time you find for a high tide in Souk, and low tides occur 48 minutes earlier. If you were waiting for the tide to fill in to get through a shallow channel, these time corrections could affect your decision when to go. Next, you need to apply height corrections. But there is an added wrinkle here. There are height corrections for high and low tides as well, but for each there are corrections for mean tides and there are corrections for large tides. So for example, at point no point, the height correction for mean high tides is 0. And the height correction for large high tides is -0.1 meters. Then the correction for mean low tides is also 0, and the correction for large low tides is +0.1 meters. But how do we know what is a mean tide and what is a large tide? To find this, we go to Table 2. Here, for Souk, a mean high tide is 2.8 meters, and a large high tide is 3.4 meters. And remember, these are all heights above chart datum. A mean low tide is 0.9 meters, and a large low tide is 0.1 meters. Remember, a large tide isn't a high tide, it's a tide with a large change. So for a low tide, 0.1 meters is a larger change than 0.9 meters. When you look up the high and low tide heights for Souk in the primary station tide tables, if the high tide value is closer to the mean value in Table 2, then it's a mean tide, and you'll apply the mean high tide correction from Table 3. If it's closer to the large tide value in Table 2, you'll apply the large high tide height correction from Table 3. Then you'll apply the low tide height corrections in the same way. In this particular example, the tide height corrections aren't significant to worry about if you're applying a healthy margin of safety already. I hope that wasn't too confusing, but you can watch it again. And you can also step through the example provided in the tides and currents tables to make sure it's all clear. Okay, that's the end of this lesson. I hope that was all clear. The next lesson will be about currents in passes and how to use the currents tables. If there's a large change in the tide, then a lot of water has to flow through some passes, and currents can be very dangerous. We'll look at how to determine the safe times to transit a pass in the next video.